So we're going to read the questions in the problem, and then we'll go to the problem and get the information that we need as we go through each part. Okay, so in part A, we want to know how many gallons of water leak out of a tank. So we're going to look and see in the problem, did they give us how many gallons leak out? And they didn't, but they gave us that we have water leaks out at a rate. So if they gave us a rate and we need to know how many gallons, we're going to go ahead and antiderive that rate. When are we going to antiderive that rate? It's going to be from 0 to 3. Then for part B, we want to know how many gallons of water are going to be in the tank. So we've got water that leaks out, so we know that we're going to lose whatever gets leaked out. And then in the problem, it does say that water gets pumped in, and that's also at a rate. So we're going to have to figure out how much is going to get pumped in. And then we also can see in the problem that the tank contained 30 gallons, so we started with an initial amount. So to figure out how many gallons are going to be total in the tank, we need to know what we started with, how much we pumped in, and then how much leaked out. Then we read part C, and it's asking for an expression called A of T, and again for the number of gallons of water in the tank, but this time it's at a time t, not at a time 3. So we're going to be doing the same thing that we did in part B, but this time we'll be doing this at a time t and not a time 3. Then in part D, they want us to look on the interval from 0 to 120 and figure out if the amount of the water in the tank is a maximum. Well, how do you figure out the amount of the water in the tank? Remember, they gave us an expression called A of T that we're going to be figuring out in part C, and we want to know when this is going to be a maximum, so we're going to need the derivative of that amount of water in the tank, setting equal to 0 to get the critical numbers, but if we need a maximum, we need to see when A prime is going to change from positive to negative. So in part A, we made our plan that we were going to antiderive the rate of the water leaking out of the tank. So to find out how many gallons leak out of the tank, antideriving from 0 to 3, that rate equation, which was the square root of t plus 1 dt. Then antideriving, you use substitution. U is equal to t plus 1. Derivative of that is just going to be dt. So our integral is going to be the square root of u du. We need our u value, so replacing in the value of 0, we've got 1. Replacing in the value of 3, that's going to be 4. Then antideriving to make 2/3 u to the 3 halves from 1 to 4, following the fundamental theorem of calculus, replacing in the value of 4, subtract replacing in the value of 1 to get our answer. Okay, in part B, we were going to use that starting amount. So the starting amount we had was 30, and then we were going to add on whatever was getting pumped in, and so the pumping in was going to be antideriving that rate of 8, and we're going from 0 to 3, and then minus whatever leaked out we just figured out in part A, which was that 14/3, and that's going to give us how many gallons of water are in the tank. So that's going to make 30 plus antideriving 8 is just going to be 8t from 0 to 3 minus that 14/3. So we have 30 plus 24 minus the 14/3. Okay, in part C, we said we were just going to use the same information that we just did for part B. So we're going to write an expression for A of T. So they said label this A of T. Total number of gallons of water in the tank, same thing we did in part B. So we had the initial amount of water, which was 30, plus then we antiderived the rate of the water being pumped into the tank. We went from 0 to 3, but now we have to go from 0 to t. Then we're going to take away antideriving from 0 again to t of the square root of t plus 1 dt. Now the problem looks a little awkward having those t's there, so instead of writing dt there, I'm going to go ahead and change that into dx and dx. All right, in part D, we're going to take the derivative of that A of t equation that we just made back in part C. So the derivative of A of t, derivative of the 30 is going to be 0. Derivative of that integral is just going to be 8, following the fundamental theorem of calculus. And then deriving the integral would make the square root of t plus 1. So we'll go ahead and set this derivative equal to 0 to get the critical number. We've got the square root of t plus 1 is equal to 8. Squaring both sides, we'll get t plus 1 is equal to 64, and then t is equal to 63. So then on our A prime number line, critical number of 63, but not testing beyond 0 or 120, because remember, the limitations on t were from 0 to 120. So I'm going to go ahead and test 3, substituting into our derivative. We've got a positive value and then a negative value. So that means A prime is changing from positive to negative, which means that the function a of t would increase and then decrease, so the two endpoints would not need to be checked. So now we'll answer the question. The amount of water in the tank is going to be a minimum at time is equal to 63, and that's because a prime is positive on the interval from 0 to 63, and then a prime is negative on the interval from 63 to 120.